We're now starting chapter 3, which is quadratic functions, and our first topic is max and min. Since most common word problems are asking us in one way or another to find either the zeros or the vertex, then that's what we're going to focus on today. If a question says a publishing company wants to make as much money as possible, would that be a vertex or a zero? So as much money as possible, you're looking for a vertex. What if the question says, when will the rain hit the ground? Well, that's a zero. So what you have to do is find out what the question's asking for. So remember, zeros, another way of saying zeros, it's the same thing as the x-intercepts. When you're given an equation already in a certain form, you want to try to squeeze as much information out of it as possible with, of course, as little work as possible. So when given an equation in a certain form, how do you find the following? So let's standard form. Let's see what an equation looks like in standard form here. Let me just write one. Say we have y equals 2x squared. I'm just making up a question. Minus 5x plus 1. That's standard form. If you have a question in standard form, how would you solve? Which means find the zeros, which means the roots, the x-intercepts. How would you do that if you started off in standard form? Well, one thing you could do, if possible, is factor. So if it's possible to factor it using those trinomial methods we talked about in the last chapter, you would factor it. And if you can't factor it, what do? You would use a quadratic formula. Quadratic formula. If you can't factor, you're going to use a quadratic formula. So when you're in standard form, that's how you would solve or find the x-intercepts or the roots. Now, how would you find the maximum or minimum? Again, you're in standard form like this. How do you find the maximum or minimum? To find the maximum or minimum, there's a couple of ways to do it, but one way is to complete the square, because completing the square finds you the maximum or the minimum. There's another way, but we're going to talk about that in a minute. So right now I'm just kind of reviewing what you did in grade 10, and you may have done something else in grade 10, but this is the only one I'm going to focus on right here. If you're in standard form, completing the square is the best way, because this really means you're looking for the vertex, if you're finding the maximum or minimum. Now, how would you find the y-intercept? So the y-intercept is the easiest thing to do with standard form, and in standard form, the y-intercept is just this value right here. So it's just the c value. The c value is a y-intercept, or you can sub in x equals 0, or in this case, that's just going to work out to be the c value. Now, what about if you have an equation in vertex form? So we're going to ignore the k value for now. The vertex form we're used to from grade 10 is maybe -3 as an a value, x minus 2 squared plus 1. That's vertex form. So the easiest of these three things to do or to find when you are in vertex form is the vertex. So in vertex form, all you do is you find the, last year you called them h and k, it's just the d and c values. That's the vertex. So that's the easiest thing to do when you have vertex form. It's harder to find the zeros or the roots or the x-intercepts. So there's a couple of things you could do here. One thing is you could convert this form back into standard form. So if I convert it into standard form, then I would go back and look at the box before this one here. So convert to standard form, and then you would go back over here to this box. You would either factor once you're in standard form, or you would use a quadratic formula. Another thing you could do is sub in y equals 0 into the equation here, because when you're looking for an x-intercept anywhere on the x-axis, let's say that point there, its coordinate would be maybe 2, 0. Over here, its coordinate is -1, 0. So if you're looking for x-intercepts, you can let the y value equal 0 and solve. Sometimes that's hard to do. So let me erase this arrow here. So you can convert to standard form, or you can let y equals 0 and then isolate x here. So bring the 1, in this case subtract 1 from both sides, divide by -3 and so on. So that will give you another way to get your x-intercepts. We've already talked about the vertex. Now how about to find the y-intercept? So to find the y-intercept, it isn't just the same as it was last time. This last number isn't the y-intercept, although unfortunately your textbook uses the letter C here and the letter C here. They're not the same C, so that can be confusing. So we are going to just the same thing we did before, sub in x equals 0. And then when you sub in x equal, or in function notation, that would be f at 0. Sub in f at 0 and then isolate to find the y-intercept. The next form that you have learned is called factored form. What's factored form best for? Factored form is best for finding the zeros, of course. So you isolate each bracket here. That's an interesting pen. Isolate x in each bracket. And that will give you the zeros. So that's the easiest one to find. Each bracket. So once x is isolated, bracket, you will have your x-intercepts. And how about finding the vertex? The vertex is a little harder. To find the vertex, there's a couple of things you can do. Once you know your 2 zeros, like say right here, we've got these 2 zeros. Once you have your 2 zeros because you're in factored form, and that's what factored form gives you, you can find your equation of the axis, which is halfway between your zeros, right? And we'll do this later. Find equation of the axis. That's halfway between your zeros. Find equation of axis. That gives you your x value of your vertex. X value of vertex. I'm trying to write really small here. It's messy. That's the x value of vertex. Once you find that, then you sub that in to your equation to find the y value. Sub in to find the y value of your vertex. You can also, of course, from standard form, you could expand it out and you can get right back to standard form and find your vertex this way. So you can always go back to standard form to do this. And the last one in our chart is from factored form, how do we find the y-intercept? So the y-intercept in factored form, same thing, you're going to sub in f at 0. And then, so that's subbing in x equals 0. Let x equals 0, and that will get you your y-intercept. I'm going to scroll up here. To find the vertex, you can also use this formula, x equals negative b over 2a, which is the equation in standard form. When the equation is in standard form, this tells you the vertex, the x value of the vertex, then you can sub in for the y value. You may have learned this before. This little formula, it's okay, but the problem with it is you're just subbing into a formula to get an answer. You don't really understand what maybe the process behind it, but let's take a look here. So we'll do the first example. Find the vertex of this function using negative b over 2a. So the vertex, we're going to sub in first x equals, we're finding the x value first, our negative b, that would be a negative 12 over 2a, that's 2 times negative 3. That gives me 12 over negative 6 or negative 2. So that's the x value, that's all equal to x. That's the x value of the vertex. So here's an x and y axis. When x is negative 2, that's my axis of symmetry. My vertex is going to be somewhere there when x is negative 2. That just gives me that value. Now I have to find the y value. I have to find where this is. Here's my vertex. Well, I can see from the equation that it opens down, so my vertex is going to be above the x-axis. Is it there? Is it up higher? So we have to find the y value now. So I'm looking for f at negative 2. So we're going to sub that in right here, f at negative 2. I don't have a lot of room here, so I'm going to put it underneath. F at negative 2 is going to be negative 3 times 4, that's 2 squared, minus 12 times negative 2 plus 15. So that is negative 3 times 4 is negative 12, and then this is a plus 24 and a plus 15. So add that all up, and we get 27. So we've got a vertex here. Oops. Just change colors. My vertex is negative 2, 27. Now let's try the same question, but we're going to complete the square instead. So by completing the square, so this is a little harder for some of us. I'm going to move it up here. So my equation is f at x equals negative 3 x squared minus 12x plus 15. So to complete the square, the first step in completing the square is to bring that a value, negative 3. So x squared is now isolated, but I also have to divide the negative 12 by negative 3. That's going to now be a plus 4x, and that's that. Okay, it's kind of like I'm doing some partial factoring. I just took the negative 3 out of the first two terms. Now my next step, I've got two terms in here, but I'm trying to make a perfect square. It's completing the square. I'm trying to make a perfect square trinomial. So to do that, I take half of this number, which would be a 2, and then I square that. That'll be 4. So it just happens to be the same number that was there. So I add 4 and I subtract 4, which seems like a bizarre move, but what that's doing is this line right here is exactly the same as the bracketed part above it. I've just added in 0. So now I'm going to create a perfect square trinomial. I just want 3 terms in the bracket, not 4. So I'm just going to take the first 3, 4x plus 4. Now this negative 4 comes out with the 15, and I have to multiply it by whatever was in front with a negative 3. So negative 4 times negative 3 is positive 12. So our next line is going to be our answer. Negative 3 is here. Now I'm going to factor this piece here. And the way I factor that as a perfect square is I take the square root of the first term, which is an x squared. So the square root of the first term is an x. This sign here, whether it's positive or negative, and the square root of the back term is a 2. Squared plus 27. So our vertex is, actually let me change colors for this one here. Vertex, it's the same as the one I had before, negative 2, 27. Same as over here. So both of those methods will find the vertex for you. That's how to use this little formula up here. Example 2, determine the maximum or the minimum value. So it's just looking for the y. If it were a parabola like this, right? I just want the y value. Say that's a 10. That's just a y value of 10. That's what this means right here, just the y value. So this is factored form. We're given an equation in factored form, and we want to find the maximum or the minimum value. So I'm just going to look back up here again. When I have factored form, when I have a question in factored form, how do I find the maximum or minimum? How do I find the vertex? So I've got a couple of things written there in black, right? I can find the equation of the axis, whoops, or I can sub in and then sub in. So let's go back down. So I have factored form is what I have, and I'm looking for the vertex. So let's get a little visual of what we have here. We know the zeros because we have factored form. So the zeros are at this one here. It gives me an x-intercept at negative 1/2. So it's negative 1. There's negative 1/2. This one gives me an x-intercept of 3. 1, 2, 3. And it opens down and it has a stretch factor. So I know my vertex is going to be above the x-axis. So where is the axis of symmetry? What's halfway between negative 1/2 and 3? So we're really looking for a midpoint. If you remember your midpoint from grade 10, halfway between negative 1 and 3. So we take an x value, we add on our other x value, which is negative 1/2, and we divide by 2. So it's 3 minus a half for a numerator, so 3 minus a half is going to be 2.5, and you can use decimals here. 2.5 divided by 2, that is 1.25, but if you're using fractions, let me write it like this. So 2.5 is 5 over 2, that's 2.5 is 5 over 2, and I'm dividing by 2. 5 over 2 divided by 2 is 5 over 2 times 1 over 2, so it's 5 over 4, or 1.25. So there's our equation of the axis of symmetry right here. So my vertex is going to be somewhere on that dotted line. This isn't the answer yet. Look at the original question. The question said, determine the maximum or minimum. I haven't done that. All I've found is the axis of symmetry. So I actually have to go and substitute now, and that's what it said up there in your chart. You have to substitute in to find the y value. So let's do that. F at, I have my x value. I can use 5 over 4. There were no decimals in the question, so I really should not be using decimals in my answer here. I should be using all fractions. So this is good practice anyway. 5 over 4. F at 5 over 4 equals, if you have not yet learned how to use your fraction button on your calculator, you should, you can usually find a little YouTube video, but it's really, really easy. Let me just finish writing this out or I'll lose what I'm talking about here. 5 over 4 minus 3. So the fraction button on your calculator looks like this. It's an A with a B, C usually, and above it, like your second function or your shift is usually D over C. So this is giving you improper, and this is giving you mixed. So for example, just do this one first. If you do 5 over 4 minus 3, so how you type that in your calculator is you do 5, then you hit this button, and then you hit 4. If you hit equals, it will probably convert it to, and it'll look like this, maybe 1 and 1/4, something like that. It'll have some kind of symbol in here. You don't need it in mixed, but you want to take that number and you want to subtract 3. So give that a try right now. And if your calculator is giving you something like this, -1 and then a little, some kind of symbol there, all the calculators are different, and then a 4. Some of them will put it in a fraction, put it in a nicely ordered fraction for you. So it might be giving you just this. We want to convert that to an improper fraction, so you're going to hit your shift button or your second function button or something like that, and you're going to get -7 over 4. So that's what goes in here. I'm going to have to erase all this stuff here so I have room to write. Actually, let me just change colors. Maybe that'll allow me to keep everything there that's there. So let's just switch colors here. So under here now, this is a -7 over 4. Let's do, and let me do the, I'm going to leave this -2 alone. Let's do this other bracket now. So try it on your calculator if you want to. Try using your fraction button on your calculator. You have to do it in order. You have to do 2 times 5 over 4 first, and then add 1. Okay, you got to convert that to a mixed number. Improper, and that should be 7 over 2. So now again, with your calculator, you can do all this multiplication if you want to. I'm going to do a little bit of canceling here, because this initial 2 is over a 1, right? So I know that this 2 and this 2 will cancel out. I've got 2 negatives that will cancel out. So what I have left here is on the numerator, I have just a 7 times a 7, that's going to be 49, and a denominator of a 4. So that gives me a value of either 12.25, or your final answer is easiest to put in a mixed number. It makes more sense to think of 12.25 and looking over here at my dotted line, 12.25. Now I know kind of where that is. If you leave it as an improper fraction, which is 49 over 4, that's a little harder to think about when I'm graphing. What is that? I would have to convert it anyway. So in your final answer, it doesn't matter if you write it as a mixed or improper, but if you're graphing it, usually a mixed is a little easier to look at. Now, is this a maximum or a minimum? Which one is it? It's a maximum because it's the top of the vertex. Max value is y equals 12.25. So let's keep on moving here. Example 3, use the following table of values to determine whether or not the relation is quadratic. Use first and second differences. The first thing you have to look at is, are my x values in order from low to high? Yes, they are. And are they increasing evenly? Are there even intervals? Yes, they are. They're all increasing by 1. So we can go ahead. If we weren't, we'd have to reorganize the table to make sure the 0, it went from low to high. But this is good. So the first part of your, if this was grade 9, these were called first differences. And all together, they're all called finite differences. So these were first differences. And our first differences are found by taking a y2 value and subtracting the one before it. So this is a y2, a -5, and I'm going to subtract the one before it. I'm going to subtract a -3. So -5 subtract 3 is really -5 plus 3. That's a -2. So we keep doing that. We take a y value, -3, and we subtract the one above it, -5. So this is -3 plus 5. That's a 2. Next pair is 3 minus -3. Well, that's 3 plus 3, 6. And 13 subtract 3 is 10. So this tells me my first differences are not constant, so this is not linear. First differences are not constant, they're not the same, so this relation is not linear. So now we're going to go on and do second differences. Second differences. And it's basically the same thing we did for the first differences. We take, except we use the first differences. I'm going to take this 2, and I'm going to subtract the number above it. That's a -2. So that's 2 plus 2, 4. Do it again. 6 minus 2 is 4, and 10 minus 6 is 4. So this proves that we have the data in the table represents a quadratic relation. The data is quadratic since the second differences are constant. So I'm going to skip what I wrote here in bold. Let's go down and just look at this vocabulary for a second. Demand, revenue, selling price, cost, profit, and number sold. Those are all vocabulary words that you need to know for some of the homework questions. And also important to know is when you're combining two linear functions with multiplication, you're going to get a quadratic function. So if I take 2x plus 3, that's linear, times x minus 7, that's linear, I'm going to get a quadratic. And that's often what happens in these types of questions here, is we have two linear functions that we put together and we multiply them together. And here's the big example of that, this formula that I have down here. Revenue means money coming in, any money coming in. You pick up a quarter off the ground, there's revenue. But generally for the problems we do, it's the demand times the numbers sold. And so another word for demand doesn't seem intuitive, but price is the amount that you're asking for your product, and the number sold, we use X for that. So that's an important formula. So we're going to go back up to this part here now, and I know I don't have a textbook in front of me, so I'll read it off. As you continue through senior math and into university, you will more and more be expected to teach yourself using resources available to you. We'll read through example 3 together on page 151, 152. And in the future, you're going to read through the examples yourself and make your own notes. So this is just, when I was in university in math classes, the lectures were relatively short compared to how much time you had to actually study and look stuff up on your own. So that's just what I'm kind of showing you here. So there's a question in the textbook that talks about the demand for a new magazine. Just write it out here. They've got the demand function for a new magazine, which, remember, demand is price, and they even use a P for it. They have P at X equals negative 6x plus 40. So that's the demand function for a new magazine, and this is in thousands of dollars. And the magazine sold, the X, remember X is the number sold, and these are also in thousands for this question. So that's the price, and then they also have a cost function. The cost function is c at x equals 4x plus 48. And the question says calculate the maximum number. Of course, we're looking for a vertex maximum number. So this formula is shown right here in your textbook. This one to tell you how to find the revenue. And the other formula that's important for you to know is what profit is equal to. And your profit is equal to the revenue. That's all your money coming in, and then you subtract your cost from that. So those are some formulas that are important for any of these revenue questions. And when you get to some in the homework, I encourage you to look through that example to see what was done there. And there's also a communication tip on page 151, and that says the demand function is the relation between the price of an item and the number of items sold. So it's giving you some definition for some of these words here, because the textbook uses all of these words, and you might need to look them up every once in a while to make sure you have an understanding of revenue and demand and cost and price and everything like that. So that's it for our lesson on kind of a review from grade 10 quadratics. And you did a lot of quadratics in grade 10, so this is a lot of stuff all put together. Work on your homework and let me know if you have any problems.